discuss here how to recognize a range of sensor and actuators in the control system. We need to discuss how to write an algorithm to represent the process. We need to discuss the flow chart. We need to discuss the advantages and disadvantages of different control technologies. So let's go ahead. Before I start, I have a few questions with you. Do you know that sensor is a type of input device, and why is that? Can you give a reason?
Because it's not outputting any data, it's just gathering the data. Like जो भी वो डेटा लेके वो डेटा अंदर लेके आ रही है.
Yes, that's an excellent answer because any data that you are trying to add in is basically through these sensors, right? The second part is that do you know that monitoring system, or can you define me that how monitoring system is different from control system? How it differs?
Uh, like I don't really know.
Like I just gave you the difference between monitoring and controlling, or if I make it more simple, you can say that monitoring is the process of observation. Monitoring is the process of tracking the performance to gather data. For example, I am monitoring you as an IT teacher to make sure that you are not cheating in your exam. For example, I am monitoring you to make sure that you are on the right path. What is this? This is your observation. This is when I am tracking your performance and I'm gathering your data. The same is the example I gave you in the patient's area where when we have a patient in an ICU, it is monitored for all of the readings, right? But when I talk about controlling, it's more about the actions you are taking. You need to understand that whenever we are working with monitoring, we are not taking an action, we are just monitoring as how the things are going on. But when we work onto the parts to make them control or to make them interact, so this is the controlling part. So controlling is basically the process where you use the data to take any corrective action or may proceed towards a goal or to complete any action. So this is what is happening in this controlling is that you are actually taking a action, but you are not taking the action when you are monitoring. So I there are some number of examples that I have shared with you on the WhatsApp, and let's discuss these examples regarding this monitoring and controlling. Okay. So the first example I shared with you is basically the primary action. Whenever you are monitoring something, it's like you are watching it, you are observing it, you are gathering the data, and you are tracking it. This is only monitoring. But when you are controlling, this means you need to take action. You need to make some changes. You need to guide behavior and activities. What is the purpose of monitoring? The purpose of monitoring is to provide you feedback, identify the actions. What is the purpose of controlling? The purpose of controlling is to make sure that you are meeting your required goal and objective. If I talk about the nature of monitoring is only observational, but the nature of controlling is you have to take the action. Are you getting my point?
Yes, sir.
So you use monitoring systems and control system every day. They are the important part of your life, but the system help with tasks such as keeping the temperature of your fridge at correct level. In this example, can you identify that is this an example of monitoring or controlling? Which one is
Keeping the
this?
temperature or the I think you can control this, so this is controlling.
I would say that this is both.
Yes, yes. This is both because you're monitoring the temperature, and after monitoring it, you're controlling it as well.
Your compressor is actually monitoring it and controlling it as well. Similarly, we have the concept, yeah, we have the air condition as well, which has its thermostat. So that thermostat is also being used to like control and manage this at the same time. So they can keep you safe in workplaces that may be dangerous. So a monitoring system could collect data about the temperature in your local area. So this has to be reported. What is a control system? A control system could help you keep a chemical factory worker safe as it will make sure that production process is done correctly. So the worker is not exposed to the chemical for dangerous amount of time. So when we talk about monitoring system, this is a system that observes and often record the activities in a process. And when we talk about the control system, this is managing or regulating the process by taking actions by physical changing aspects of the system that is dependent on the collected data. Do you have any confusion till here?
No, sir.
Okay. Now let's move on to the next area. uh, The next area, sensors. So, what is basically a sensor? A sensor is a type of input device. We have discussed this already. The basic definition of a sensor is that it is used to collect data about physical environment automatically. So this can remove the need for a human to collect the data manually. Like you don't need to stay there and collect all the data memory. The data is collected from a sensor and it is input into a system to take any necessary required action. What is a sensor? The basic definition is that this is an input device that collects data from the surrounding physical environments. However, there are several advantages of using a sensor to collect the data. The first advantage that we have right here is that data can be repeatedly collected 24 hours a day. This means that a human does not needs to be present at all the time and can rest as well. Data can be collected in a harmful and dangerous environment as well without the need for humans to be present. So it's like if I am talking about some heated areas, like maybe in factory or maybe some parts of the world where it could be quite dangerous for humans to stay there. So we can use the sensors to gauge the temperature. This means that life of the humans will not be endangered and you can still do that. The third part is the sensor. A sensor may be more consistent in the data that it is simply as it is a mechanical device. So it is therefore likely to be accurate. A human may be inconsistent, so this could lead in some of the errors, but a sensor is always consistent because it has the computing abilities. Now, first question is that what kind of things you can, oh, this is the one, like see, what kind of things you can see, hear, or feel in your environment. So, if you are going to answer to this question, you can see that maybe the temperature, the level of sound, the level of height, the movement. So, there are more things that are changeable about the environment as well, but they are not seen there. Like, for example, you can talk about the level of moisture, you can talk about the level of humidity, you can talk about the electromagnetic fields, you can talk about the amount of pressure. But if you attempt to create a sensor to collect data about all these different aspects of the environment, it would probably needs to be quite large because when you are trying to collect the data, it is important that sensor is quite small so that it fits in the convenient place and it records all the levels. So for example, some of the examples of sensors are you can take the example of light, UV sensor, you can take the example of temperature sensor, you can take the example of pressure sensor, humidity sensor, sound sensor, infrared sensor, touch sensor, electromagnetic sensor, proximity sensor.
So,
Yes. Yes, you have a question? Do you have a question?
sir, understood.
Okay. Here is a question. It says it may be obvious for some of the sensors collect data about, for example, light and sound. What sort of data do you think some of the less obvious sensors would collect? Do you have any idea about infrared, electromagnetic field, touch sensor, or proximity sensor?
Yes, infrared, like infrared is like a wavelength of light. I think like some
Okay,
like wave type of wave, and electromagnetic field, like touch sensors, like basically touch proximity is how far away or how close something is.
okay. And what about electromagnetic touch and proximity?
Touch like is like physical touch, and
Okay,
proximity is how far, how close an object or person is.
okay, okay. That's correct. Now, we have actually learned that there are advantages of using a sensor, but there can be disadvantages too. So, the biggest disadvantage is that a sensor can be subject to wear and tear and it can may become faulty. This might make it start to provide incorrect readings, so this could be detrimental. For this reason, sensors needs to go through the process of calibration. Do you know what is this calibration?
Calibration, like to correct something.
Uh, Wait. I mean, have you used any sort of measuring device that is being used to calibrate to its certain weight? Like, let's say this example of this weight. Have you seen this?
I've sometimes like used this as well, but like hardly.
Yeah, sometimes. I mean, before using that, what is the first thing we do? We need to calibrate this. Calibrate means,
So it will start at zero.
yeah, this is calibration. This is known as calibration when you are setting the value so that you get the accurate value for what you need. This is calibration, right? So calibration is important. Why is that? Because if you have an inaccurate set of data, it could be useless. So it could be very dangerous if that data is being used in a control system and you need to take some important actions based on that. So it's like, I hope that you have been traveling to Pakistan. I mean, do you travel maybe once a year?
Yes, sir.
Yeah. So even before traveling, do you weight all your bags? Do you weight all your luggage before going?
Yes,
And how you do that? Do you have a machine at home or at airport?
machine at home.
Yeah. So before you use that machine, do you make sure that that is set to zero?
No. Yes, yes.
Yes, obviously. This is calibration to make sure that the data that is being collected by the sensors is accurate and then can be put into a process through calibration. So no sensor will be absolutely perfect, but it is important to make sure that readings are taken as accurate as possible. So what is calibration? Calibration is the process of testing and modifying a device to make sure that it is taking the correct reading. So to calibrate a sensor, you need to have a calibration reference, that is the standard. I mean, if you want to calibrate against, a simple method of calibration is to test readings against another sensor to check if it is properly calibrated or not. Another way is using physical references or other references. For example, you use a ruler or a measuring tape so that you can have two values and you can compare both of them. Even when you talk about sensors, they have a characteristic curve as well, like a curve map to which the sensor responses in comparison to that. So there are three main categories of results that can be given by a sensor. The three main categories of the sensor are: the first one is known as an offset, the second is known as the sensitivity, the third one is known as the linearity. When we talk about the offset, this means that the readings are higher or lower than the ideal reference. When we talk about sensitivity, this means that readings change over a range at a different rate to the ideal reference. We also have the concept of linearity. This means that readings are directly proportional to the ideal references. See, this is the concept of offset. There are three different types of calibration that you can use as a sensor: 1 point calibration, 2 point, and multiple point. 1 point calibration is the simplest form of calibration. It can be used to correct an offset calibration curve as well, and this is because the sensor is reading partly corrected as it is changing the same rate, but it just consistently, like if it measure too high or too low, so the sensor can be calibrated based on a single reading. But there are definitely different methods of how to calibrate them. Like one simple method could be take a reading with a sensor, compare the reading with the measuring device, as I told you, subtract to get the offset value, add them to calibrate the value. So these are certainly ways as how you can calibrate them. Like for example, if a thermometer tells you that temperature of a room is 22, but the reading from the sensor says 20, you are going to minus and you will get the offset as 1.5, which means that this needs to be added if you are calibrating them. So 2 point calibration can also be used to correct a data that sets both of these values. So it basically rescales. So there are different methods. So one method is that if you take two different readings with your sensor, it works best. If you take a reading at the lower end of the scale and reading at the higher end, so you can basically compare both of them. Then you can calculate the range by subtracting the low reading, and you can calculate the range as well by using the formula. So for example, if a temperature sensor measures the temperature of an iced water at 0.75 and a boiling kettle at 98 Celsius. So you can use these 2 point calibrations. One is the minimum and one is the highest to make sure that you are getting the accurate readings. You can apply the formula. You can also work with multiple calibrations as well, that is similar to how the other calibration methods are, but it is performed using different readings. So, but this is like increasing your accuracy because if you have more number of readings, that means you can calibrate the sensor and would produce more readings. So, what a sensor has collected the data will be sent to the computer system. Then we have 3.3. 3.3 is where we are going to discuss about the monitoring systems.